And welcome to question 14 of the 2023 Junior Cert Higher Level Maths. So this question here, the last question on the paper, is revolved around, I suppose, more advanced trigonometry, okay, and problem solving. So it's worth 15 marks, but part A and B are marked together, and I have them both on the page here. So we'll read through. The diagram below shows a triangle ABC. Now it's not drawn to scale, so this is the triangle, ABC. You notice there it's a right angle triangle. Okay, so that might be important. Then the points D and E lie on the lines AC and BC respectively. So there's AC and there's the point D, and there's BC and there's the point E. So that's all cool. Okay, everything that is given in the text is given on the diagram. They acknowledge that the angle CAB, so this one here, is 90 degrees. They acknowledge that the angle DEC, okay, here is also 90 degrees. Again, all reflected on the diagram. So the question then says, work out the value of x. Now, I'd suggest that you could use a variety of different methods, but focusing in on this smaller right angle triangle might be more beneficial. So if I was to redraw that, then it would look something along the lines of this. There's your right angle, so it's 90 degrees. And it's always worth writing the 90 degree on there, just so you acknowledge you know it's a 90 degree triangle. This hypotenuse, the side opposite the right angle, is 15. This side here is 9, and this side is x. So the second I realize I'm working with 90 degree triangles, I'm either going to explore using Pythagoras if I'm only trying to find a side and I have the other two, or the sine, cos, tan ratios, okay, which are just relating the different sides of a right angle triangle to the angles, okay. So this looks to me like this is Pythagoras, okay, except in this situation, I'm given the hypotenuse, so it's not this straightforward. So I'm given that C is 15. Now I could call A 9, and B is the, I don't know, is the x value, okay. Once I substitute that in, it's going to be 15 squared is equal to 9 squared plus x squared. Now at that stage, I can convert them into numbers, or I can deal with them as powers. It's irrelevant really. But I want the x to stay on one side, and I want the numbers to go over to the other side. Now a simple way to do that is to take the number I want to get rid of away. And if I do that to one side, I have to do that to the other side. So I can end up with 15 squared minus 9 squared is equal to, now this is cancelled out, there's 0, and I'm left with the x squared. Now if I want to get rid of the square, and one way to get rid of anything is to do the opposite to it. So if I square root the x squared, I'm okay to do that as long as I square root everything on the far side. And then I'm left with x is equal to, now if I bring my calculator up, so the square root of, now they're all positive, but I'll just use brackets. I always should in a calculator if I can. Take away 9 squared. Now that gives me an answer of 12. So x is equal to 12. Now I have the answer on the next page, and that's it there. Okay. Now I'll keep going here on B, using the answer done out. So it says using similar triangles. So triangles can be different sizes. Okay, so they're not congruent, but they are similar in many aspects. So it could be like a triangle, small and a bigger one. They're similar, not congruent, because they might have the same angles, and maybe it's 90, 60, 30, and maybe the exact same here. Obviously, you probably can't see what I'm writing there, but they're similar. Okay. Now you can relate similar triangles. So they are both right angles. This one here, we're looking to work out the value of y. So we have a triangle here that we can relate to a bigger triangle here. And that's what we're trying to do. So if we relate the sides, DC, so the 15 here, and relate that to the longer side here of 24, okay? So the hypotenuse of this smaller triangle, comparing that to the hypotenuse of the larger triangle, that's the 15 over the 12 plus 12. That's what gives me this 24. Now on the far side, okay, I'm relating the side DE which is the equivalent to this side here, even though the triangles are flipped. And this, I appreciate, is a cognitive thing. You can always redraw them and just take your time. But those two sides can be related, and that's 9 over the we don't know, which is the y. So this statement has only one unknown, which we can solve for. Now, what I'm doing here is I'm going to bring, for speed, I'm bringing the y across. It's divided on the right, so it'll be multiplied on the left. And the 24 here is divided on the left. When you bring it across to the right, it'll be multiplied. So I end up with this statement, 15y is equal to 9 times 24 is 216. Now, the simple way to get rid of the 15 in front of the y is to divide it by 15. If we do it to one side, we have to do it to the other, and then we're mathematically correct. So 15 divided by 15 is cancelled, and you're left with 216 divided by 15 gave me a value of 14.4. Now that, if you put it to the BS test, it should be at least be bigger than the 9. Okay, 14.4 is bigger, so it's not giving me any reason to be suspicious. I'm not given units, so there's no reason to worry about them. Although you could always just say, if you wanted to cover yourself, just say units. Okay. Now, that should be the end of question 14. So as always, if you want to copy these notes, send me an email at shanetroy@gmail.com. Like and subscribe to get access to more playlists. Thanks.